students, so finally we have reached the end topic of this course, Probability and Statistics. So the last topic in this course is here, curve fitting. So what is this curve fitting? What is the use of this? So here this curve fitting is useful to find the means to fit the data and to interpret the data when the data is of very big size. So here in this curve fitting we have the application part, fitting of straight line, fitting of parabola, fitting of exponential curve and fitting of power curve. So what is this application part here? If you see that different types of curves we have. So first if you see the fitting of straight line, right? So we are considering here two variables where one is a dependent variable and the other one is an independent variable. So if one variable is increasing, what is the effect on the other variable? That can be found using this straight line here. And also we can predict the future values in this straight line. And you can see that application means the graph of this straight line, right? So straight line means here always the data will go either in increasing order or in a decreasing order. Then the next curve is here second degree parabola. Parabola means for the parabola example you can consider this banana. So banana is in the shape of a parabola here. And the other example is the satellite dishes. So when the satellite dishes are moving here, so in the directions whatever they are moving, right, they have to follow that entire the parabolic curve, means the angles they have to take here. And next the third curve is the exponential curve. So we know that here the exponential curve is of two types. That is y equal to a into e power bx and y equal to a into b power x, right? So the difference between the straight line, parabola and exponential. In straight line here we have only two constants a and b. But whereas in a second degree parabola we have three constants a, b and c here. Now coming to the exponential, so always this exponential curve is a growth curve also we can say, means always it is in a rising manner, right? So here you can see the graph, right? So you can see the graph of this COVID-19, right? So here the data is given from the April to June. So always the number of cases are increasing here. The last curve is here power curve. And this power curve is also known as a complex curve here. So you can see the application of this power curve, the wind turbine, right? So as the speed of the wind increases here, the electricity generation also will take fast. So that can be done with the power curve model only, right? Now if you see that here the curve fitting also means we can fit the curve by using the different methods, that is a graphical method, method of group averages, method of moments and method of least squares. But in this syllabus, in this curve fitting here, we are going to discuss the curve fitting using method of least squares. So this method of least squares was introduced by Leysander. So according to Leysander here, the minimization of the sum of the squares of the residual error gives the best fit to the given set of data. So according to that principle only, if you see the straight line, the equation is here y equal to a plus bx. So we have two constants a and b. So we will be having two normal equations according to the principle of least squares here. So the normal equations are summation y equal to n into a plus b into summation x and summation xy equal to a into summation x plus b into summation x square. So that means here we have to consider the y minus a minus bx whole square as the residual error e. Then we have to differentiate that partially with respect to the two constants a and b and we have to equate it to 0. Then we will get these two normal equations. Then for the second degree parabola, the equation is of two forms here. We can consider y equal to a plus bx plus cx square and also y equal to ax square plus bx plus c. So if we consider the equation y equal to a plus bx plus cx square, means here we have three constants a, b and c. So we have to differentiate the equation y minus a minus bx minus cx square with respect to a, b and c partial, right? Then we get the three normal equations. That is summation y equal to n into a plus b into summation x plus c into summation x square. Then the second normal equation is here summation xy equal to a into summation x plus b into summation x square plus c into summation x cube, and the third normal equation is here summation x square y equal to a into summation x square plus b into summation x cube plus c into summation x power 4. And here you can see the parabolic graph also. So always it will be in that direction only. Means it will be first it is rising, then again it is decreasing here. Then the other form of the parabola is here y equal to ax square plus bx plus c. So the difference between y equal to a plus bx plus c x square and y equal to ax square plus bx plus c is that only the coefficients of a and c will interchange, but the b coefficient remains same only. So the three normal equations for y equal to ax square plus bx plus c are here summation y equal to a into summation x square plus b into summation x plus n into c, where n is the number of observations. Second normal equation is here summation xy equal to a into summation x cube plus b into summation x square plus c into summation x. And the last normal equation is here summation x square y equal to a into summation x power 4 plus b into summation x cube plus c into summation x square. So in the problem, if nothing is mentioned about the form of the parabola, then by default you can use y equal to a plus bx plus cx square. If specifically they have mentioned fit a parabola of the form y equal to ax square plus bx plus c, then you can use these three normal equations. Right? Then the third curve is the exponential curve here. So exponential curve is of two types, that is y equal to a into e power bx and y equal to a into b power x. Right? So first we have to bring this exponential curve in the form of a straight line here, because the principle of least squares is applicable only for a linear data here. Right? So for that, first if you consider y equal to a into e power bx, we have to consider the logarithm to the base e on both sides. Then the normal equations will be summation v is equal to n into capital A plus b into summation x, and second equation summation x into v equal to capital A into summation x plus b into summation x square. Now what is this v and capital A? V is nothing but the logarithm values of y with respect to the base e here, and capital A is nothing but log a to the base e. Right? Then you can see the exponential graph also. Right? So for y equal to a into b power x, you will get the graph like this. We are having the different values here. Right? Then the next type of the exponential curve is here y equal to a into b power x. So the two normal equations for y equal to a into b power x is here summation v equal to n into capital A plus b into capital B into summation x. Now this time here b is also capital, and summation xv equal to capital A into summation x plus capital B into summation x square, where again v is nothing but log y to the base e, and capital A is log a to the base e, and capital B is here log b to the base e here. So you can see that y equal to a into b power x graph, right? Always it will be in a rising way only. Okay. Then the last curve is here fitting of power curve. So the power curve equation is given by y equal to a into x power b, right? So for this also we have to consider the logarithm on both sides. Then the two normal equations will be here summation v is equal to n into capital A plus small b into summation u, and the second normal equation is here summation uv equal to capital A into summation u plus small b into summation u square. Now this time here we have to consider the logarithm for the x observations also. So logarithm for the x observations is taken as the variable u here, and for y we have taken an exponential, that is capital V, and capital A is nothing but log a to the base e. So finally the power curve is in the form of, again this is also in a increasing manner only, right? So this is about the fitting of power curves. I hope you understand these curves. Let us solve the problems on straight line.